Hi guys, very good evening. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I am going to discuss basics of formal languages in theory of computation under fundamental series of GATE 2024. So please quickly join and mark your presence. And please do like the session and share with your friends. And yes, yeah, today I am talking about the formal languages of theory of computation. Okay, join quickly and mark your presence. I hope I am audible and visible to every one of you. Am I audible? And please confirm me once if my audio, video, everything is clear. Okay. Yes, join quickly. Am I audible and visible? Please let me know. Okay, that's fine. Yes, please let me know. Okay, so before I start the session, so let me introduce myself. Myself, Muralikrishna. I'm having 21 plus years of teaching experience, both in the GATE and also I work in different engineering colleges. And I am a topper of Theory of Computation in the NPTEL course, and I'm certified as International Engineering Educator through ISIP certification program. And I have mentored more than 50,000 students across the country in different core areas of computer science and engineering. Those are theory of computation, operating systems, computer organization, computer networks, digital logic, and ICT. And this is about my brief profile. Yes, join quickly and mark your presence. Hello, Bhuvendra Singh. Good evening. Yes, fine. Thank you. Fine. Now coming to the small information regarding the free workshop. So we are having a free workshop on comprehensive preparation strategy for GATE 2024. It is live on 25th April. That means tomorrow only at 7:30 p.m. by Sanjay Rathi sir. He is having 20 plus years of teaching experience. So please make use of this and register for this free workshop. And please do share this class information with your friends and just do like the session. Okay. And I hope I am audible and visible to every one of you. Am I audible? Okay, fine. That's fine. Now you can just say hi or hello. Now coming to results of GATE 2023. So this is the success rate of 2023 GATE aspirants. So we have appeared and got the result. 62 students got all India rank under 50 and 13 students we got all India rank under 10. 107 students all India rank under 100. And these are some of our toppers. Dhruv has got 5th rank in computer science and Gautam has got all India first rank in the instrumentation and production and all India rank 4th and 5th in instrumentation electrical Sarv Verma. These are the toppers. Hello, Mohammad Azad. Yes. Good evening. Am I audible, Azad? Yes, that's great. I hope I am audible and visible to every one of you. Please do like the session and share with your friends. Okay. Yes. Now let me continue the session. So today's topic is basics of formal languages. Okay, you see this. So these are the different types of formal languages. First, you have regular languages, context-free languages, context-sensitive languages, and then recursive languages and recursively enumerable languages. Am I audible? Yes. So if I am not audible, please do let me know. Okay, fine. Now, in these formal languages, in this especially today's topic, we will learn about what is a formal language, what is a grammar, what is the relation between the formal languages. So why these formal languages are originated, who invented those languages and their theory of automata. This is what the basics required for theory of computation. Now coming to the syllabus of the GATE, as you know, regular expressions and finite automata, then context-free grammars and push-down automata, regular and context-free grammars, pumping lemma, Turing machines, recursive and recursively enumerable languages. So these are the things. Okay. And in this series, I will try to cover as many topics as possible. So please try to attend the class every day at 9 p.m. Okay, na? Also, share this information with your friends. Is it clear? Am I audible? And please do like the session, share with your friends. Yes. Okay. Now coming to undecidability also there. So first of all, in the formal languages, we study about alphabet and grammar. So alphabet is nothing but the symbols we are using for framing the sentences in the language. Okay. And grammar is set of rules for framing the sentences. So for any language, we require to have a grammar. So grammar is nothing but some set of rules for framing the sentences, which gives proper meaning. A language is a formal language only if it has a formal alphabet and formal grammar. Okay, but there are so many languages for speaking purpose, but there is no script, there is no grammar. Those are some tribal languages in India are not having formal grammars, but we only for speaking purpose. But there are formal languages like English, Hindi, Telugu, all other languages, official languages are called formal languages with formal alphabet. But the formal languages, what we study here, for making a computer to understand the languages. So we have to make a machine to understand the languages. So in this regard, we are having a formal language and an automata theory. Automata is nothing but it is a mathematical representation or machine characterization of a formal language. Okay, like finite automata, push-down automata, linear bounded automata, Turing machine. So that is called the machine characterization of a language. It is also called as a mathematical representation of a language. Hope you are understanding. And please share with your friends. Yes, yes. Muhammad, yes, Azjad is asking, sir, do we need to study discrete mathematics for TOC? Actually, if you have finished discrete mathematics, that will be great for understanding in detail of sets and relations research wise. But in the GATE point of view, and the way I am teaching and also the content what I have considered, will be covering basics required for understanding the subject also. So without discrete mathematics also, you can attend TOC, but without the TOC, you can't attend the compiler design. That sequence you have to follow. I hope it is clear, Azad. And have you shared with your friends this class information? Fine. Now let's move on to the next slide. So basically, a formal language is an abstraction of a general characteristic of programming languages. So we are having different programming languages like C language, Pascal, Fortran. Okay, all these languages originated from the basic set of formal languages invented by Noam Chomsky. So there is a Chomsky hierarchy of formal languages. So basically, a formal language consists of set of symbols and some rules of formation by which these symbols can be combined into entities called the sentences. Formation of sentences is a collection of words, and words are basic of some symbols, alphabets. Okay, and formal language is set of all sentences permitted by rules of the formation. That is formal grammar. What do you mean by alphabet? Alphabet is nothing but any character that is defined in certain notation. Okay. So what is that notation we use? Okay. Just a moment. So what is the notation? A finite non-empty set sigma of symbols called the alphabet. Example, an alphabet with two symbols is sigma is equal to 0, 1. Okay. And also strings are finite sequence of symbols from which alphabet. For example, alphabet 0, 1, for example, and formulation of strings like 0, 1, 0, 1 is a string over alphabet 0, 1. 0, 0, 0, 1, 1, 1, 0 is also a string from this alphabet. Okay, that is a strings in the language. And grammar is nothing but some rules are there. Actually, it's a mechanism of describing the study of languages mathematically by using some rules. So in these rules, actually, we represent four entities like variables, terminals, productions, and starting symbol. And when we study in detail about the grammars, you will understand how to represent a grammar language wise and based on the type of languages. Okay, now are you following? I hope I am audible and visible to all of you. Am I audible? Yes or no? Okay, fine. So if you have any doubt in the chat box, you can ask your doubts and don't hesitate to ask your doubts, please. Okay. Yes, yes. And please use this live chat box as much as possible for clarifying your doubts. Okay. Now coming to This formal language automated theory, the syllabus will be like this. Okay, you have to cover all those things for getting 70% marks in the theory of computation. Regular languages, regular grammars, finite automata, and context-free languages, context-free grammars, and push-down automata. Then you will have context-sensitive languages, context-sensitive grammars, and linear bounded automata. But in syllabus, context-sensitive grammars are not there. CSL, context-sensitive languages, are not there. Okay, and Turing machines are there. That is a recursive and recursive enumerable languages. For that unrestricted grammar, that those are accepted by Turing machines. Okay, this is a general outline of all the four types of formal languages. This type of hierarchy is called Chomsky hierarchy. Chomsky hierarchy of formal languages. So finite state machine accept the regular languages, and DCFLs, deterministic contextual languages, and normal CFLs, then Turing machines, decidable and undecidable languages. This is a hierarchy. So every regular set is a DCFL, every DCFL is also CFL, every CFL is recursive, every recursive is also recursively enumerable. This is a hierarchy of formal languages which we are going to study. Okay. So every CFL need not necessarily be regular, but every regular is a CFL. That Venn diagram says like that. Okay. And non-partially decidable and non-computable languages. That means there won't be any computation for those languages. Okay. This is the relation between the formal languages. If we see regular languages were represented with regular grammars, those are called type 3. And context-free grammars are represented with context-free grammars, context-free languages, type 2 grammars. And context-sensitive is a type 1 grammar, and recursive enumerable languages and recursive languages type 0. These are the four types of formal languages. I hope every one of you are following. If you have a doubt, please ask me. Don't hesitate to ask your doubts. Okay, na? Yes. Okay. Shall I continue? Relation between formal language and formal grammars is this. And please do let me know if you have any doubt. Yes. And coming to relation between formal language and formal grammars, you see, regular languages type 3, these are recognized by finite automata. Finite automata power is only to recognize regular languages. And pushdown automata can accept regular languages as well as contextual languages. It's more powerful than finite automata. And linear bounded automata can accept all context sensitive, which are context free and also regular. And a Turing machine can accept all the categories of languages. Okay, so Turing machine is more powerful among all these four types of formal languages. So that is a relation between these formal languages, grammars, and automata. So what do you mean by the term automata? Automata is nothing but, it is a general meaning of automata is it is a system or model which can do the activities on its own automatically without the human intervention. But in this context, automata is nothing but it is a language recognizer or a machine counterpart for a languages, formal languages. Why these formal languages are invented by Chomsky? For development of computer languages. All computer languages like C, C++, and Java, all these languages are originated from the basic set of formal languages only. Okay, na? Yes, Azhar. Sir, formal languages are the one understand by computers. Exactly. They can be recognized by the computers by way of designing the compilers. Because this finite automated theory is used, theory of computation basics are used, and machine models are used in the designing phases of compilers. Every programming language should have a compiler to compile it, to identify the errors by scanning the program, right? So that is the criteria. Okay, na? And please do subscribe the channel and share with your friends. Okay, na? Just a moment. Okay, fine. Now let us continue. Relation between the formal languages and automata we have discussed as of now, basing on the their Venn diagram. Now let's see what is alphabet and what is a string. Basically, alphabet is nothing but a finite non-empty set. It is shown in the sigma actually. Sigma is a input alphabet set. called the alphabet. Example, an alphabet with 3 symbols like sigma is equal to a comma b comma c. And similarly, we can have an alphabet like sigma is equal to ABC defined over some alphabet, finite sequence of symbols, ABC 0, 1, etc. Let us suppose if you wanted to know the length of the string, for example, W is equal to AB. Length of the string is defined with a notation like modulus of W, where W is a word. And what is alphabet for this word? Alphabet sigma is equal to A comma B. And what is the length of this word? Length of this word is 4, modulus of W. And a null or empty string is having more importance theoretically in formal languages. Null string or empty string is represented with lambda, and some textbooks will represent like epsilon, some textbooks will represent like cap. So these are all different notations, but the meaning of this is empty string or null string whose length is 0. Length of a null string or empty string is 0. So any string whose length is 0 is called a null string. Yes, Azhar. Fine. Now coming to formal language definition. Formal language is an abstraction of general characteristics of programming language, and we can combine the entities of different strings to make a sentences in the language. And formal language set of all sentences permitted by the grammar. Grammar is represented like this, already I have told you. And examples of formal language, let's see. So let us suppose if we take formal language L1 is equal to A power n B power n. So in this example, alphabet for this language is A comma B. Alphabet for this language is A comma B. And what are the sentences in this language? So A followed by same number of B's. So AB is one sentence, AABB is one sentence. When n is equal to 1 AB, n is equal to AABB. N is equal to 3, triple A followed by triple B. Hope you are following. Like that, we can have infinite strings. N value 1, 2, 3, 4 and so on. So language L1 example. Now language L2, A power 2i such that I greater than or equal to 0. I greater than or equal to 0. If I value is 0, A power 0 is epsilon. If I value is 1, it is 2s. If I value is 2, it is 4s. If I value is 3, it is a 6s. Like this it will go. So this is set of even number of a's. And alphabet for this language, we can define it as A. So for every language, in this throughout the subject, we will learn about how to construct a machine counterpart like finite automata, pushdown automata based on the type of language, regular, CFL, and etc. And also we represent grammar. Okay, so that is a task here. Okay, I hope if you have any doubt, please do ask me, and don't hesitate to ask your doubts. So this subject is very interesting subject, and please try to attend the classes regularly, daily at 9 p.m. Okay. Yes or no? Fine. Shall I continue? Okay. Now one more example. Let us suppose if you take L3, WC W power R, where W is a string of zeros and ones. 0, 1 whole star indicates W is any string of zeros and ones. W power R is reverse of W. In this alphabet is given as 0, 1. That means a word is formed with zeros and ones. And we are having C also. Alphabet is not only 0, 1, and one constant is also there, C. And the smallest string, when W is epsilon, its reverse also epsilon. C is the minimum string. When W is 0, reverse is also 0. 0 C0 and 1 C1. 0 1 C1 0. Okay. And 1 0 0 C 0 0 1 and 1 1 0 C 0 1 1. So this type of strings are present. Okay, and you will also have 1 1 0 1 C 1 0 1 1 reverse. So this type of strings are present. If you carefully observe what type of pattern we are going with in a language, then we can decide the type of language, whether it is regular or context free or context sensitive. Throughout this subject, the study is about this only. Okay, and by the time we finish the subject, you must be able to classify the languages, whether it is regular or not, whether it is context free or not, whether it is context sensitive or not, and how to make a finite state machine for a language, how to make a pushdown automata for the language. The entire study goes like this. Okay, and this is the basic idea I wanted to give. And one more example I will tell you. If you take A power I, B power J, for example, this is the J. Ij greater than or equal to So I value greater than or equal to 1, j value greater than or equal to 0. It means that minimum string is a, I value 1, j 0. And we can have 2s also, because I value 2, j value 0. 3s also possible. And also I value 1, j value 1 also possible, ab possible, abb possible, triple ab possible, like this. Any number of a's followed by any number of b's, but number of b's minimum 0, j value 0. So only a's also possible. That is a language L4. Now if you take L5, 0 power n, 1 power n, 2 power n plus m. So alphabet for this language is sigma is equal to 0, 1, 2. 0, 1, 2. So for every 0 and 1, number of 2's are added actually. So if n is 1 and m is 1, for example, 0, 1 followed by 1 plus 1 is 2. So 2 times 2 will come. If n value 2, m value 1, so 3 2's will come. If n value 1, m value 3, for example, 4 2's will come. Like this. We can have n plus m number of 2's. This is the pattern. N zeros followed by m ones followed by n plus m 2's. Hope you are following. Yes. Azad is asking, sir, can you show how to represent grammar? Yeah, definitely in the coming chapters I will represent, because if I start explaining the grammar representation, it may take 1 hour for only representation to understand. Only basics I am telling you right now. So if you can understand the pattern of language strings, then grammar you can understand, machine you can understand, everything you can understand. Yes, Madhavi. Hi, sir. I'm looking for Nail It course, but in app it is not available. It is there now. It is there. Nail It course is going on right now. Please search with Nail It keyword, and you can subscribe. Okay, fine. And please do share the channel with your friends. And now coming to L6, a power p is prime, means prime number. Number of a's are prime. So what is the prime number? 2 is a prime number, 2a's. 3 is a prime number, 3a's. Okay, 4 is not a prime number, 5 is a prime number. We can have 5a's. Next 7a's. So this type of a's will come. So alphabet for this is only a. Actually, to know whether the given number is prime or not, some computation is needed here. So based on the pattern of sentences in the language, we can classify the whether it is classify the type of the language. Okay, hope you are understanding. Now coming to some more languages. A power I, B power J, C power J, D power I. That means B's and C's are equivalent, A's and D's are equivalent. I and J are independent. Say for example, I am taking I value 1, J value 1, you will get A, B, C, D. If I take I value 2, J value 1, you will get A, B, C, D, D. If I take J value 2, I value 1, you will get A, B, B, C, C. Here the criteria is B's and C's must be same, A's and D's. So for every A, D will come. For every B, C will come. Like this pattern goes. Okay, now L8 is A power I square, I is integer. So number of A's are perfect square. If I is integer 1, for example, 1 square, it will be single A. 2 square, 4 A's. And 3 square, 9 A's. So number of A's are perfect square. 9 A's. Again 16 A's. 1 square, 2 square, 3 square, 4 square, like that it will come. And L9, if you observe, A power I, B power 2J plus 1. J value 0 and I value 1. So minimum number of B's are 1, A's are 1, I greater than or equal to 1. So that means AB is a minimum string. And 2A's followed by B is also possible. 3A's followed by B possible. And 1A followed by, when J value is 1, 3B's are also possible. 1B, 3B's, and even 5B is also possible. Number of B's are odd. Number of A's are any number. Number of B's are odd. Okay. Similarly, W power R. This pattern already we have seen in WC. C is separating its reverse, but here there is no separation. If W is epsilon, reverse also epsilon. W0, reverse is 0. 1 1 is possible. 1 0 is W, 0 1 is W power R. 1 1 0 W, 0 1 1 W power R. 1 0 0 0 0 1. So this type of string. So these are all even length palindromes. We can also call it as a palindromes of even length. Palindrome means a string reading same from left to right and also right to left. Is it clear? Everybody following? Left to right and right to left. If same pattern is followed, that is a palindrome. Reading same. Okay. Now coming to A power I, B power J, C power I, D power J. So B's and D's must be same. A's and B's must be same. A's and C. So here minimum string is A, B, C, D. As A's and C's are same, if I value 2, A, B, C, C, D. And if you take B value, D value are same, for example, A, B, B, C, D, D. And so on. Like this. Pattern will be like this. And L12, A power 3I, B power I, B power J, this is. I greater than or equal to 0, J greater than or equal to 1. So this is A power 3I and B power J. Such that I greater than or equal to 0, that means 0 or more times, so multiple of 3, and J greater than or equal to 1, any number of B's. So if I value 0, we can have single B or double B, triple B, any number of B's possible. And even if I value, for example, if I have taken I value 1, for example, we will get 3A's followed by B possible. I value 2, 6A's followed by B possible, like this. Number of A's multiple of 3 followed by 1 or more B's. Now coming to L13. X such that X is a string of A's and B's. Number of A's of X mod 3 0. That means B's can be any number. There is no restriction on B's. This type of pattern. Actually, the language format, definition format can be taken from any textbook. So that's why I'm just explaining all the things. Upload this PDF in Telegram group. Definitely, Azad, don't worry. I will upload it. Okay, today's class, Telegram group, I will upload this PDF. Okay, don't worry. Including these annotations. Clear? Okay, now coming to the strings, actually, number of A's of X mod 3 0 means it should be multiple of 3. So that means any number of B's are possible because A's are 0. 0 is a multiple of 3. And if A's are there, it should be multiple of 3. For example, A possible. B's can be any number, 0 or more. So AB, A possible. A, B, A possible. So this type of string. Total number of A's must be multiple of 3. And L14, A power n, B power n, C power n, A's followed by B's followed by same number of C's. So ABC is one string, A, B, C, triple A, triple B, triple C, this type of strings. And L15, 0 power n, 2 power m, 2 power k, n is equal to k. So zeros and 2's must be same. So better you take it some 3 just to differentiate, and m greater than or equal to 0. 0, 2, 3. So n is equal to k means m value greater than or equal to 0 means, so 0, 3 possible, okay, and 0, 2, 3 possible, 0, 2, 2, 3 possible. So 2's are independent, 0's and 3's are similar. Okay, now coming to L16. I hope you are following, right? If you don't follow, please let me know. Length of the string should not be multiple of 3. So what is the criteria here? Yes. Length of the string should not be multiple of 3. So that means string length 0, epsilon not acceptable. Single 0 okay, single 1 okay. Length 2 is okay. And length 3 is a multiple of 3. It is not okay. Except length 0, length 3. Length 0 means epsilon. Length 3, length 6 like that. So length 4 also can be acceptable. Okay. And AB whole power I, C power k, I is equal to k. So that means for every AB, C should come. So if you have something like epsilon is also possible. Okay, I value 0, k value 0. So AB followed by C and AB followed by CC. For every AB, one C should come. And W belongs to any combination of A's and B's and C's, and number of A's must be equal to number of B's. C's can be any number. For example, I am taking A, B, C, C. It is acceptable because number of A's are 2, number of B's are 2, but C's are any number. For example, I am taking CAB, it is acceptable. CCAB, it is acceptable. BCAAB is acceptable. And C's can be any number. Total A's must be equal to total B's. Like that, we can take the pattern. Hope you are following. Do you have any doubt in this? And like this, I'm just giving you some of the languages as your homework. Here, just I will tell you the representation. NMKL, N plus M should be equal to K plus L. It is like, for example, N value 1, M value 2, A, B, B, and C value 2, D value 1. This is also okay. 3, 3. 1 plus 2 is 3, 2 plus 1 also 3. Like this, we can get the strings. Here, not having consecutive A's. So that means epsilon is not having consecutive A's. Single A possible, single B possible, AB possible, BA possible, AB possible. Okay, BA possible. After A should not come. And W is string of A's and B's and C's. Number of A's of W mod 3 not equal to 0. Number of A's should not be multiple of 3. That means single A is okay. 2A is okay. A okay. AA okay. B's can be any number. Okay, this type of strings. Now you can take these strings also as an example, and you can do just take it as a homework. I will share this PDF in the Telegram group, and all of you join in the Telegram group. You can explore the valid string in these examples also, L22, 23, and 24. Okay, and these 25, 26, and also 27. These examples you can explore the strings. At least we can practice, because I have just shown you total 21 languages, and I'm giving you 6 languages as an example for you. So these 6 languages you can take it as homework, as I am sharing the PDF with you. I hope you people have enjoyed the session, and please do share with your friends, and also do like the session. If you are not yet subscribed, please do it so immediately. Okay, thank you so much. Thank you one and all. Have a good night. See you all. Bye bye.